All right, it's been a little bit of a while, so I thought we could use a refresher on graphing exponential and radical functions. So first off, we're going to graph f of x equals 1/2 raised to the x power. So that is the same thing as 1 to the x all over 2 to the x. But 1 to any power is going to be 1. So it's also the same thing as 1 over 2 to the x power. All right, let's put in some x values and then see what we get for y. So we'll do -2, -1, 0, 1, 2, and 3. So first off, we have 1 all over 2 all to the -2nd power. Now, remembering our negative exponents, that's actually the same thing as 2 over 1 to the positive power of 2. Well, 2 over 1 is just 1. So this is 2 squared, which is 4. So we have the point -2, 4 on our graph. So this is going to be -2, and it's going to be pretty high up here actually, around 4. Then we have -1. I have 1/2 raised to the -1 power. Well, remembering what we know about negative exponents, that's the same thing as 2 over 1 to the +1 power, because I made the exponent now positive, which is the same thing as 2 to the first power, or 2. So I have the point -1 up 2. Now I have 0. 1/2 to the 0th power. Hopefully you remember that anything to the 0th power is 1. So now I have the point 0, 1. Then I have 1/2 to the first power. 1/2 to the first power is 1/2. So I have the point 1, 1/2. Now I have 1/2 squared. That's the same thing as 1 over 2 squared, which is 1/4. So really we're taking a half of a half of a half, which is why we keep on having our y values here. We're going to half our y value again, because I have 1/2 to the third power. That's the same thing as 1 over 8, because 2 to the third is 8. So I mark my point 3, 1/8. Now I just connect all my dots, and I have a very nice looking exponential function. However, this exponential function is graphing a fraction, which is why, for this example, the exponential function starts very large and gets very small. So it looks a little differently. Remember, the ones with the integer greater than 1, we go up that way. But now that we have a fraction, a positive fraction, it looks like this. All right, for the second one, I wanted us to remember as well how to graph radical functions, especially when they've been transformed. So first, the fact that it has this square root, that's what makes it a radical function. This square root thing, that's why it's called radical, because that's what we term a radical in mathematics. Now this 2 is multiplied by x plus 1. So this is a stretch of 2, so it basically makes it 2 times taller. This plus 1 inside the radical is the same as moves 1 unit left. That's the tricky thing about being inside the radical. When it's positive, it moves left. So now let's put in our x values and see what we get for y, though we have a prediction of what the graph should look like depending on the transformations, because really it should just be the normal square root of x function, but 2 times taller, and then move 1 unit left. So let's start by putting in -1. Now I'm going to start by putting in -1 because I know it moves 1 unit left, so it should start at this point of -1. Now I have 2 times the square root of -1 plus 1. So first I do what's inside this radical because of order of operations. -1 plus 1 is 0. 0 times 2 is 0. So I have the point -1, 0 on my graph. Now I have 0. 2 times the square root of 0 plus 1. First I do 0 plus 1 is 1. So it's 2 times the square root of 1. Well, the square root of 1 is 1, so 2 times 1 is 2. I have the point 0, 2. Now I put in 1. 2 times the square root of 1 plus 1. Ooh, unfortunately, my video cut out there for a second. But just whatever we missed was we did 2 times the square root of 1, which was 2. So then I plotted on my graph. 0, 2. And then I put in 1. And then I saw that this 1 plus 1 is 2. But I don't know the square root of 2 off the top of my head. So that's actually why I'm going to skip the point of 1 and just have it go to the next integer that will give me a very nice square root, which would be 3, because 3 plus 1 is 4. So now I do 2 times the square root of 4. Well, the square root of 4 is 2, and 2 times 2 is 4. So I have the point 3, 4. Keep going. Now I'm thinking about what would be the next value that is nice to put in here. Well, the next square root that I know of is 9. Square root of 9 is 3. So if I put in an 8 for x, 8 plus 1 would give me 9, and then I would have that nice square root. So let's put in 8. 2 square root of 9. Well, 9 is 3. 2 times 3 is 6. So I have the point 8, 6, which isn't quite on my graph. 6. And then we also want to do our last point of 15, because 15 plus 1 is 16. And we have a nice square root for 16. 2 times 4 is 8. So it's going to be up around 8. Then I connect my points. And this nice radical function here is my 2 times the square root of x plus 1. So we see it's been moved to the left 1 and stretched by a factor of 2. All right, hopefully this has been a good refresher of exponential functions and radical functions for you. Oh, my niece is coming in. And that you will now use this to do your problems.